All right, we are going to start to dive a little bit deeper into graphing sine and cosine. So in this video, we're going to start to shift those graphs. But first, just to reiterate, okay, a couple of things we already talked about. The domain of both sine and cosine is all real numbers, or negative infinity to positive infinity, because these graphs are periodic. They continue on forever in both directions. The range is just -1 to 1, including both of those values, and the period is 2 pi. Okay, now as we start to shift our graphs, these things could change. Okay, the range could change, the period can change. Okay, but if there are no shifts, the range is -1 to 1, the period is 2 pi. Okay, so before we start to shift, I just want to re-look at these graphs again. Okay, so here is one period of sine, okay, from 0 to 2 pi, and this includes all the points from the unit circle. Okay, now we mentioned multiple times now that sine would continue on forever. This is what it would look like if we go an extra period in the positive direction and an extra period in the negative direction. Okay, it looks exactly the same from 0 to 2 pi as it does from 2 pi to 4 pi, or from -2 pi to 0. Similarly, for cosine, okay, we have our one period of cosine from 0 to 2 pi. Again, this includes all of the x values from the unit circle. Okay, but we would, if we continue on in either direction, right, it looks exactly the same as it does from 0 to 2 pi to 4 pi, or -2 pi to 0. Now, as we start shifting, one thing that's going to be very important is knowing the general shape of sine and cosine. Okay, so the general shape of sine, we start at 0 and then go up, back down, and finish at 0. The general shape of cosines, we start at 1, go down to -1, and then finish up at 1. Okay, those two general shapes are going to be important as we start shifting. So let's take a look at what those shifts will mean. So we talked in the first semester about shifting all kinds of different functions. So what we're really going to be doing something very similar, right? If we've got an a, b, a c, and a d value, and these are in the same exact locations as when we shifted things like a quadratic or a cubic or a square root function. Okay, the a value here is just a vertical stretch. Now, we will use sometimes different words. We're going to use the word amplitude here when we're talking about a sine or cosine function, okay, but it's still just a vertical stretch. The b value is a horizontal stretch or compression, right? We used the word stretch or compression when we talked about this in the first semester. And we can call this a period change. Okay, this value is going to change the period. A c value is a horizontal shift, so that'll move the graph left or right. And then if we have a d value, that is a vertical shift, so that would move the graph up or down. So we're just going to look at two of these today. We're just going to look at a values and d values. Okay, and these would obviously be the exact same things to the cosine function, right? Vertical stretch, horizontal shift, vertical shift. Okay, so let's start with what if we have an a value. Okay, so I mentioned that was called an amplitude, and it's just defined as the distance from the midline to the minimum or the maximum value. Okay, and the midline then is a horizontal line through the middle of a sine or cosine graph. If there is no vertical shift, if there is no d value, the midline is just the x-axis. And we'll look at examples here in a second where the midline is shifted, where there is a d value. Okay, but first, let's go through an example that just has an amplitude. Okay, so we want to graph y equals 3 times the sine of x. Now, to do that, we really need to think about key points. Okay, so key points, okay, that we're going to use on these graphs, we're going to use 5 key points whenever we're graphing, okay? Whenever we're graphing any of these shifts, we're going to have wherever we're starting, the maximum, crossing the midline again, the minimum, and then back to crossing the midline for one period of sine. And then for cosine, we're starting at the maximum, crossing the midline, minimum, crossing the midline, maximum, okay? No matter what our shifts look like, we always want to graph those 5 points and label those 5 points very clearly. So, to graph sine, okay, what I want to start with is saying, well, instead of going from 0 to 1, I'm going to be going from 0 to 3, okay? If my amplitude is 3, that means the maximum value is 3. So I'm essentially just taking this graph and stretching it so that this value is 3, and then this value is -3, okay? So let's label our graph. So we'll start at 0, 0, and then let's say 1, 2, 3, -1, -2, -3, and then our values on the x-axis, if there aren't any horizontal shifts or stretches, they'll always be the same values, right? We'll start at 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi. Now, I just went a distance of 4 spaces in between each one. It doesn't really matter as long as you use the same value, right? I could have gone 5 spaces and put pi over 2, then 5 spaces and put pi, right? Just as long as you're using the same distance on your axis here and labeling clearly, okay? So now, if I'm graphing sine, I know the general shape of sine is to start on the midline and go up, back to the midline, then down, then back to the midline. So I'm starting at 0, 0. Then my next key point is at pi over 2. So instead of pi over 2, 1, since I have an amplitude of 3, I'm going to be at pi over 2, 3. Then back to the midline. Then my next key point is at 3 pi over 2. Then -3, since my amplitude is 3. And then back to the midline. So my graph should look something like this. Okay, now we are only graphing one period, but to denote that this is going to continue on forever, let's put some arrows on the ends there. Okay, so here is one period of sine. So again, when we are graphing these, okay, when I grade this, what I'm looking for is those 5 key points, so that you're essentially clearly labeling the axes. Okay, I can clearly see that this point starts at 0, 0. This point is at pi over 2, 3. This point is at pi 0. This point is at 3 pi over 2, -3. And this point is at 2 pi 0. Right? So the amplitude just vertically stretches our graph. Okay? So let's now look at if there is a d value, okay, a vertical shift. So this is when we're adding or subtracting some value outside of the trig function. Okay, we're saying the midline gets shifted. Now, what that means is if I'm looking at these versions of my graphs before any shifts, the midline, okay, is the x-axis. I'm going to shift that up now. Okay, I'm going to say the midline is now at +2. So I'm going to sketch that in. Right, let me put this in with a dotted line. So I'll go every 2. So we'll say 1, 2. Here's my midline. Okay, so here is, I'm just putting in a dotted line here for my midline. Now, we do usually want to sketch where the midline is. That's going to make things a lot easier to graph. All right. So now let's label here. So we said we were going 1, 2, 3, 4. Now you can label your graph however would be appropriate. Okay. I mean, if you wanted to go by ones here, that would be okay, right? Just as long as you clearly label and let me know where your points are, right? So now we want to label again between 0 and 2 pi. So here is 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now, since I shifted everything up, okay, since I shifted everything up, now I need to think about going up 1 from the midline, okay? So here, cosine usually starts at 0, 1, right? 1 unit above the x-axis. In this case, we're starting 1 unit above the midline. If the midline is at 2, that means I'm going to start at 3. My next value is going to come down and cross the midline at pi over 2. Then at pi, I go down to my minimum. In this case, my minimum is just going to be 1 down from the midline. So in this case, my minimum is at positive 1. Then at 3 pi over 2, I'm back to the midline. And at 2 pi, I'm back to my maximum, which in this case is 3. So when we sketch out cosine, make sure we're not just drawing a V. Make sure that it looks like a nice curve like this. And almost, there we go, that looks a little better. Now, and again, this would continue on forever, even though we're just graphing one period, so we'll put our arrows on the end to denote that. Okay, but again, what I'm looking for is just those 5 key points clearly labeled. If I have a D value, that means I'm shifting the midline up. Okay, so let's now try a couple examples where we have both an A and a D shift. Okay, so to do that, the very first thing that we want to do is sketch our midline. Okay, so here, -1, or I'm subtracting 1, that tells me the midline is going to be at -1. So I'm going to go ahead and sketch that in here. Right? So we'll put the midline in right here at -1. Okay, so then I'll label my axes. So we're going 1, 2, then -1, -2, -3. Then from the midline, right, we want to go a distance of A. In this case, my A value or my amplitude is 2. So that means from the midline, I'm going to be going up 1, 2, and I'm going to be going down 1, 2. So it's a good idea to mark that on your y-axis, right? So I know that my minimum value is -3, my maximum value is +1. And again, that's because I went a distance of 2 up from the midline and a distance of 2 down from the midline. Okay, so now we're graphing cosine here. So, well, first I should label my points on the x-axis. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so now for sketching cosine, right? So cosine, we're starting at the maximum value, right? So we said the maximum value was 1. And at pi over 2, I cross the midline. At pi, I'm at my minimum value. At 3 pi over 2, I cross the midline again. And then at 2 pi, I'm at my maximum value, which we said was 1. And then we just want to sketch in our curve. And we'll add our arrows on the end to remind us that this goes on forever in both directions. Okay, so first, sketch the midline. Find your maximum and minimum values by going up and down a distance of A, and then draw your 5 key points. Okay, let's try one more example together here. Okay, here we've got some fractions. So let's make our scale here a little bit different than what we've been doing. Okay, and again, if you want to just make this each go by one, you can. You're just going to have a real short graph, right? So, make your scale appropriate. If I'm going up 1/2 and my amplitude is only 1/2, I don't know, let's say that every 4 is a distance of 1. So let's say this is 1. So this would be 1/2, -1/2, -1. So my midline is going to be at 1/2. And sketch my midline in right there. Then we just said we're going up a distance of 1/2 and down a distance of 1/2. So that tells me that I'm just going to be going between 0 and 1 here. Right? So I probably could have even stretched that out a little bit further. Now let's label our x-axis. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this time we are sketching the sine curve. So sine starts at the midline, right? So I'm going to be starting here, then going up to my maximum, back to the midline, down to the minimum, and then back up to the midline. So here, my sine curve is going to look something like that. And again, put our arrows on the end just to remind us that this goes on forever. Okay, so 5 key points, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then just make sure you are clearly labeling the y-axis where each of these points and the midline would be. Okay, that is it for this video. The final question is going to pop up asking you what questions you have.